The Oscillator. It flips, it flops, it's totally rad. We are Group 13. I'm Chris, this is Amanda, this is Frank, and this is Steven. And basically what we did is we came up with a car that drives on one side, and then when it hits a wall or gets to its ramp, it flips over and drives back the other way. And so you can kind of see a little bit of it here up on the screen. But we're going to go into a few of the parts that we'd like to highlight. This is the front piece. You can see it right in here. Basically, this was made with a blend. I think I drew maybe 7 or 8 cross sections that this is blended through. You can kind of get the idea up there. So there's a back, and then it slowly gets smaller, and then slowly gets larger. And also the holes in there are basically due to our volume constraints, which I know a lot of us dealt with, but we had to cut out a lot of volume, and so originally that was all solid, but we came to a solution that actually we think makes it look a lot cooler. So I will pass it off to Frank, and he will talk a little bit about the back section.
The back section is our main body of the oscillator. It basically supports the motor and holds the axis and fix the gears. And this is the most likely the center of gravity of our oscillator, because once it's flipped over, it needs very light in the front but have weight in the back. This design is most likely based on the extrusion. For the hollows in the body, it's for the limited printing volume, and all the holes are measured based on the parts we purchased by using 5% tolerance. Next, I will pass to Steven to talk about our gear system.
All right, so as this red box indicates, this is a 6-speed gear box, and we use it as a power source. And underneath the output gear, there's an idler, and on top of the output gear, there's a drive gear connect with the top drive shaft, and underneath the idler, there's a bottom drive shaft. That way, we make the 4 gears have the same diameter, so they will turn the same speed. And also, because they are all external contact, eventually we make the top and the bottom wheel turn in a different direction. That's because once we encounter the obstacle, we do not want the oscillator to reverse. It will always go forward. So next slide, next video will actually prove how it works, and I will pass to the Amanda to bring us to the real work scenario.
All right, so it was difficult to model in Pro-E what the oscillator actually does, because that would require incorporating gravity into Pro-E's constraints, and that was a little difficult. So what you saw there was a video of the wheels actually turning. Here you can see a picture of the oscillator on its ramps that were designed out of wood. The ramps wouldn't have to be exactly like this. A child can build his own ramps. It could be a book leaned up against a wall. What matters most is that it is at a proper angle to allow one of the rear wheels to start up the ramp, so that when it reaches its climax, it's at a point where it can fall. So that's all that's important there. The car was put together with screws to hold the front and back sections together, and then the top and back covers were put on with epoxy. This should be okay. It should be a video showing how it works. You can see it moves a little slowly to be highly entertaining. That's part of because of the gearbox that we chose. When it got here, it has 6 possible speeds. So we chose a gear ratio of 196.7 to 1, and that was the best one we could do that had enough torque to get it up the ramp and wasn't too horribly slow. But in the future, we'd like to get a different motor that would work a little better to be more entertaining. Chris has a quick demo here of how it actually works in real life. Another future improvement would be to make it not sound like that. But again, it's the motor we picked. The whole car was designed around fitting the battery pack and the motor in. The battery pack is encased underneath those 2 silver housings, which you can remove to change the batteries and to turn it on and off. So yeah, that is the oscillator, and it flips, it flops, and it is totally rad.